A ship in port is safe, but that's not what ships are built for. Every year, ships come through the port of Rotterdam in need of urgent, critical repair. Some ships must wait weeks while replacement parts are sourced from somewhere around the world. Others take on the massive expense of warehousing a huge variety of spare parts at different ports. Soon, this will all change. FARO and Autodesk, the global leaders in 3D measurement hardware and software, have developed tools to inspect additively manufactured components. These tools helped in the certification of the world's first class-approved additively manufactured ship's propeller, dubbed the propeller. Created by RAMLab, Rotterdam's additive manufacturing laboratory, using a deposition process known as wire arc additive manufacturing, or WARM. The propeller was printed in a nickel-aluminium bronze alloy. By producing spare parts nearer to where ships are repaired, a ship's downtime can be reduced from weeks to days. The FARO scan arm inspected the propeller for imperfections to a precision level of 50 microns, an unparalleled degree of accuracy. Data from the FARO scan arm was evaluated by Autodesk's Power Inspect 3D measurement and metrology software, which verified that the propeller was built according to design and distortion-free, showing that additive manufacturing can make propellers quickly, on demand, and to specification. The propeller is just one of the parts that can be made on location. FARO's measurement tools and Autodesk software were instrumental in this process and can verify the geometry of other additively manufactured components, so replacement parts can be certified and ships can get back on the sea. Because while a ship in port is safe, that's not what ships are built for.